Okay, so it helps to know the parent graph. So for this one, you might consider starting with the parent graph, which means, y starts, the asymptote is y equals 0. Let's get a dotted line right there. Normally exponential growth, like for 3 to the x, the parent graph goes to the point 0, 1, and it kind of hits that point and moves up pretty fast, right? So that's the point starts being 0, 1. Now it may move here. So what happens is this is going to be multiplied by all the y values, right? So the y value was 0, 1. You're going to multiply it. Now it's 0, -2. So to plot that point, that's on the graph. The behavior is the same. On the left, it's approaching the asymptote, hits the point, and kind of moves down pretty quickly. So that's the graph of this function. If you want to show off, then you want to get an extra point on this. Maybe plug in, let's try to plug in 1 and see what happens. So if you plugged in 1, you would get -2 times 3 to the first is -6. You get 1, -6. You'd have to have the tick marks here. So this is 1, 2, 3, 4, 5, 6, and 1. So you have to go through this point at 1, -6. And you'd have to have the graph actually go through that point. Or you could plug in a point like -1, be a good point to plug in. If you plugged in -1, that's 3 to the -1, that's -2/3 if you simplify that. So there should be a point at -1, -2/3, right about there. Would be a point that you get a bonus point. What I'm saying is, if you put a bonus point on the test, I might give you a bonus point if you get an extra point correct. Not one for each point, but one per graph. Okay, let's try this one. Again, start with the parent graph of 3 to the x, which is y equals 0. Okay, the parent graph goes to 0, 1, goes up pretty quick, something like that. So this one's going to move it to the right 2 and down 4. I always like to move the asymptote first. So the asymptote was at y equals 0. It's going down 4. So my new asymptote is y equals -4. Be sure to always label that with the equation. The point is going to go 2 to the right and down 1, 2, 3, 4. So I think that point now will be at 2, -3. And the graph will look like this, goes up pretty quick after it hits it. If you want to get a bonus point, you might want to plug in a point near 2. So maybe 3. Let's plug in 3. So that would be 3 minus 4 is -1. So there should be a point at 3, -1, right about there. The graph should go through. Or you can plug in maybe a +1. So 1, 1/3 minus 4. Wow, that's -3 and 2/3, which is like -9, -11/3, I believe. It's a little tougher one to plug in. So it'd be 1, -11/3, somewhere around there, right there. Okay, let's try some other ones. These should be easier. They're quicker. This should be in parentheses like this. It wasn't, but it needed to be. Okay, so the rule is you can take this exponent and move it down front. So this would be 3 times log base 5 of 5. That's one way of doing this. You could just memorize the property. That would be another way. It's actually one of the properties. 3 times 1 is 3, so the answer is 3. You also could have just seen that the smiley face and the answer would be 3 if you knew the property. Again, so like if you don't know the answer, you can just set equal to x and change the form. So it'd be 3 to the what power equals 27. I hope you know that one. Hope you know 3 to the third is 27. If you don't, you could do the prime factorization of 27. That's 3 to the third, but we just know that one. The answer is 3. You might know the property for log of 1. It's always the same thing. If you don't, just change the form. 8 to the x equals 1. 8 to the what power is 1. That would be 8 to the 0 power. It's one of those properties of 0. This one, we're going to change the form. 3 to the x equals 1/9. And instead of 1/9, I'm going to write that as 1 over 3 squared. And then let's rewrite this again. So this would be 3 to the x equals, this is really 3 to the what power? To get it to move up, you can make that a negative exponent. You go, oh, x has to be -2. So -2 is the answer here. You might see the property here. If you don't, write the base. It's understood to be e here. So this would be e to the x equals e. Again, that is a property. E to the first equals e. So you got it. This also is a property. It might be best to just know the property, but if you don't, we're going to solve this. So we're going to put this into log form because that's exponential form. So it'll be natural log of e of a number x equals the exponent, which is natural log of 2. So what does x have to equal to? It has to equal to 2. You might just have seen the property of frowny face. The answer is 2. So here you need the formula. So in this case, it's continuous. So we're going to use this formula. Make sure E is a button on your calculator here. So this would be A after 6 years. So the amount after 6 years is 50,000 is the initial amount invested, times E to the power of rate, which is 0.04, times T, which is 6. So at this point, you're just going to get your calculator out, type it in 50 times E to the power of 0.04 times 6. And let's see if this answer makes sense. 63,562, if I can read that right. 0.5. You might want to consider mousing up and seeing more digits. You press enter. Actually, it's 0.46, isn't it? So even more accurate to the penny there. That would be that answer. And we'll set it up first, then we might use our calculator. Grandmother gave you a savings bond. You were born with $100. Interest is compounded semi-annually. How much money? So this looks like this formula right here, right? It's compounded with where n would equal 2 for semi-annually. So we're going to use that formula. So the amount after t years, when you were born, so 0 to 100. So the amount after 100 years, wow, that's pretty good, equals $100. So only $100 to start with. That's too bad. 1 plus the rate is the interest is compounded. How much money would the bond be worth if you look to be? Oh, we're missing some interest rate here. So I don't know. Let's say it's 5%. We're missing part of the question. So this was missing information that I should have provided here. So let's just say it's 5%. Then this would be 1.05 divided by n, which is 2, because I think it was combined as semi-annually, so 2 to the 2 times t, or 2 times 100 power. So if you earn 5% for that long, maybe you have a 100-year CD, that'd be kind of crazy. 100, let's see, 1 plus 0.05 divided by 2 to the power of 2 times 100. Well, 13,000. So it did grow 13,956.40. Well, let's check again. You can see even more digits if you want. 0.39. If you want to get, down to the nearest cent, it would be even better. Use a rule of 72 to estimate the amount of time it would take. Okay, so for 25,000 to turn into 100,000, that's going to double twice, right? So 6% a year. So the rule is 72 divided by the percent, 72 divided by 6, which I think goes in there 12 times. So it takes 12 years to double, which means it's going to take 24 years to double twice. So 24 years is the answer. It's an approximation, but it's using the rule of 72. That's called 72 divided by the percentage is how that works. Evaluate. So when it says evaluate, I want to see your work, and also you want to, you show the steps, but you want to solve it. Like it should kind of work out, hopefully, pretty nicely. I don't know log 4 of 8, but if I put this together, if I push that together, compress it into one logarithm, it might be actually not too bad. Log 4 of, I guess, 8 times 8 is 64. I'm going to say equals x, so I have an equation. So this would be 4 to the x power equals 64. So 4 to the x power. If you don't know the prime factorization of, you could know that. It'd be helpful if you just knew that 4 to the third power is 64. That's one you might have memorized. But if you don't, we could rewrite these. Actually, we could write both of them. So I think that's 2 to the sixth. I think 4 to the x is actually 2 squared to the x, or 2 to the 2x equals 2 to the sixth. So what must be true about those exponents? 2x must equal 6. So x must equal 3, which is true. 4 to the third is 64. Before you push these together, make sure you move that up to the exponent spot. So this would be log base 3 of 3 plus log base 3 of 9 to the negative 1/2. Well, that's a lot of stuff right there. Okay, so you might want to simplify that first before we kind of go forward. So negative makes it go to the denominator, and hopefully you know that, well, how about we do this? Let's change that to 3. So this would be plus log base 3 of 3 squared to the negative 1/2. Right, maybe that'll help. It's a negative 1/2. So we still have log base 3 of 3. In fact, if you want to simplify that, that first term is 1, right? This is equal to 1. You probably know that. Plus, this would be log base 3 of 3 to the negative 1 power. 3 to the negative 1 power. Okay, so we could do a couple things with this. You could put the 1 in front. So 1 plus negative 1 times log base 3 of 3. There's a number of ways to solve this. Log base 3 of 3 is 1, so this is just 1 minus 1, which is 0. Wow, after all that's equal to 0. Kind of crazy. Expand, so we're not solving. We're not going to try to find an answer. We're trying to break this apart. We don't want division. We don't want any squares or multiplication inside of the logarithms. So first, let's break it apart. Natural log of x squared plus natural log of y. And now the x squared, this 2 can move because I don't want exponents in there if it's fully expanded. So 2 times natural log of x plus natural log of y. We're done. We're not trying to solve it. We're just trying to break it apart. First step here, and you've seen this before, hopefully, is you want to write this as x to the 1/2 power. 1/2 power is the same thing as square root. Now we can move that exponent out front. So we have 1/2 times log of x. And you're done. You're not really trying to solve this. You're trying to break up the problem so that there's no multiplication or division or exponents inside of the logarithms. Now we're doing the opposite. We're trying to write this, compress this together. So you want to push this together first, take care of the exponents. Those have to move up. So I get natural log of 2 to the third plus natural log of 2 minus natural log of x minus 5 to the third power. So this is going to be, this goes together here. So this would be natural log of, I'm just going to write it like this, 2 squared times 2 minus natural log of, again, x minus 5 to the third. So this is pushing it all together. It'd be natural log of one big fraction. So 2 squared times 2, and this would be x minus 5 to the third. So solve this. They don't have the same base, but I bet we can adjust this. We did this the other day. So instead of 8, you could do the prime factorization as 2 to the third to the 2x equals, instead of do the prime factorization. What I mean by that, if you don't know that, you get your calculator out. You would type in menu 32 of 32, and you get to the fifth. You might just know that one. You've done it a bunch. 2 to the 6x equals 2 to the fifth. What must be true? The 6x must be equal to 5. So if 6x equals 5, one step to solve, you get x equals 5, 6. This one, first move that over, so you get 9 to the 2x equals, I guess, 27. Prime factorize, right? So that can be prime factorized as 3 to the second to the power of 2x equals the prime factorization 27 is 3 to the third. I like this. Now I can compare these. So I get 3 to the 4x equals 3 to the third. So what must be true? Those exponents must be equal. So 4x must equal 3 and x must equal 3/4. So solve this, we're going to change the form. That's how we solve this. 3 to the third equals 2 minus x. 3 to the third is 27, so 27 minus 2 is 25 equals negative x, so x equals negative 25. Not a bad idea to check some of these answers when they're in the logarithm here. So if I plug in negative 25, 2 minus negative 25 is 27. That's a positive number. I'm okay. Move this over to the other side first. So you get log of x equals 1. Change the form, understood the base is 10, so this would be 10 to the first equals x, so x equals 10. This one, it says round to the nearest 100. You're immediately thinking I might at some point have to use my logarithm, my calculator. So let's just put this in log form. So it'd be log base 5 of 175 equals the exponent, which is n plus 1. Subtract, sorry, get rid of that. Subtract 1. So we get n equals log base 5 of 175 minus 1 outside the parentheses. At that point, if you want the decimal, you would just type in control 10 to the x, it's log 5 of 175 minus 1 is approximately equal to 2.2091. This would be 2 to the third equals 2x plus 5. So 8 minus 5 is 3, so 3 equals 2x, divide by 2, divide by 2. X equals 3/2. This one, put it in the log. Well, let's do this one first. So push that together first. So natural log of 4x, multiply when you add. This is a base e, so let's put it in exponential form. E squared equals 4x, divide by 4, divide by 4. You get x equals e squared over 4. So if you put your calculator out, that would be e squared over 4. You get x equals 1.8473. This would be natural log of e of 2 equals x minus 4. Add 4, you get natural log of 2 plus 4 equals x. That's the exact answer. Get your calculator out. It'd be control use x, which is natural log of 2 plus 4. And you get x is approximately equal to 4.6932. To use your finance app, so we'll use this last question, right? So let's try to get this. So, okay, so we use finance if we can manage to save up every single year. So finance app is menu 8.1, I think. Always start with percent. Enter it not as a decimal when you're using the app, so 9. This is always a hard question. Is it a one-time investment? If so, it might be present value. Is it a recurring or investment that happens over and over again? Then it's a payment. Every single year you're investing $1,000. That is definitely not a present value. Present value is going to be 0 on the app. You're starting with nothing. You're making a payment, which is an outflow. That's negative of $1,000. Future value is your goal. You want $1,000,001. That's positive money because I'm going to get that money at the end. I pay money into the investment. I get money at the end. How often is compounded? Annually. Annually, so this would be 1. And the question is how long will it take? We're going to solve for n. That's multiplied by 1 because CPY is 1, so it is actually the number of years. It will take 52.3 years to do this. How long? So $1,000 every year. 52.3 years later, you'll be cool up, straight up millionaire. That's amazing. So that was the review for